All right, guys, the fourth and final topic for the Prob and Stats and unit is going to be normal distribution. So we're going to talk about how data is spread and distributed. We're going to use the empirical rule, and then we're going to use our calculator when things don't fall nicely in the empirical rule. All right, so the first topic, we don't talk much about this, and I don't think there's Delta Math questions on this, but this is a normal distribution, okay? It's also, I guess this is the normal here. This, when you have data that's roughly bell-shaped, okay, so this one goes with this one, it's called normally distributed data. When you have data that looks like this, where most of it is on the left, and the tail, we say, or the smaller part of it is on the right, we call this, it's a positive skew. So I think of it as it's screwed up on the positive end or the right end. Most of the data is on the left. But you think of that as how the tail drags to the right. So that's supposed to say positively skewed. And what that means, as you can see down here, is that the mode and the median are further over. The mode is always the top, so this is the mode. The median is the middle, which somewhere on one like this would probably be somewhere in here. And then the average is going to be drug over towards the middle somewhere because of the smaller values here. So the mean is to the right. Get into all kinds of information about that in Prob and Stats or AP Stats. But when the tail of the data is dragged to the left, it's called a negative skew. All right, I think that's all I had down for this. Data distribution in general is just the way the data points are clustered. Is spread out or clustered. Okay, so we're going to talk about data that is normally distributed, which means it has, let me go back to this picture I had here. These are all normally distributed data sets. It's just this shape is this little hill, okay, which is even on both sides. This just means there was a much smaller spread, and this blue one has a much larger spread, but they are all still that bell shape, okay? And that bell shape is called the normal distribution. So we're going to put bell-shaped curve here. Defined by a mean and the standard deviation, okay? The area under the curve represents the probability with the total area equal to 1. Now, we are going to use what's called the empirical rule to estimate how that normally distributed data, the probabilities, and then we're going to eventually use our calculator. But the empirical rule, which I always want to spell wrong, says that from the mean, if you go out one standard deviation either way, okay, one above or one below, you go 34%. So 68% of the data is within one standard deviation of the mean. 95% is within 2 standard deviations, or another 13.5% on either side. If you go out 3 standard deviations, you go to 99.7% of the data. Okay, so those are the 3 numbers. It is also called the 68, 95, 99.7 rule. meaning 68% of the data will fall within 1 standard deviation, 95 will fall within 2 standard deviations, and 99.7 will fall within 3 standard deviations. All right, so I should have put that here, I guess 68, 95, and 99.7. Okay, so for example, let's just write in here 34% and 34%. And this will be very helpful if we have this 13.5 and 2.35 and then 0.15%. Okay, that will help a lot. So, the weights of 50 football players are normally distributed with a mean of 178. So on our graph, we want to write 178 goes right here. This is the mean. And a standard deviation of 8 pounds. So what you need to do is add 8 or subtract 8 going across each way. So if you add 8, you get 186. If you add another 8, you get 194. If you add another 8, you get 202, and so on. If you subtract 8, you get 170. You subtract another 8, you're down to 162. You subtract another 8, you're down to 156. Let me check that I have those all right. 154. Yep, that should be a 154. Did I mess anything else up? Nope, I think I got those right. Okay, so what percent measured between 178 and 194? 178 and 194 is here to here. Okay, so if you look up above, it said that this was 34% and this was 13.5, which comes out to be 47.5%. And it asked for a percent, so we're done. What is the probability? Okay, so we can answer either as a percent or decimal for probability that a player weighs at most 170. So we want everybody who's under. At most means 170 or under. So what part is this down here? Well, this is 50% here, this whole half. In my brain, it's easier to do this. You can add up the little pieces if you want, but this is half, and this was 34. So if we did half minus 34, that leaves 16% to be down here, which is 13.5 plus 2.35 plus 0.15. So either way, it's 16%. or 0.16. What is the probability that the player weighs less than 162 or more than 194? So now we're talking about these people down here and these people up here. Well, if you look, remember this was 68 and this was 95. So if 95% are in here, there has to be 5% left over above and below. But you could add 2.35 and 2.35 and 0.15 and 0.15 up here, and you should get 5%. Okay? Or 0.05 if you wanted it as a probability. This is the kind you got to be a little tricky with here. And you have these on Delta Math. How many players weigh between 175 and 186? 170, I'm sorry, and 186. Well, 170 and 186 is just one standard deviation each way, so it would be 68%. But you have to finish the problem. They told us there were 50 players here. So we have to actually calculate that. So it's 0.68 times 50 players, which is 34 players is what they wanted. All right, I'm going to go a little quicker. This one says we have a standard deviation, or I'm sorry, a mean. Nope, 120 test scores. We're going to need that later. The mean is 82. That goes right in the middle. A standard deviation of 5. So we add 5, we add 5, we add 5. We subtract 5, subtract 5, subtract 5. Boy, that's scribbly writing, sorry. And then it says what percent are between 72 and 87. And we could scroll back up here and see it was 34, 34, and 13.5 would fall within those. This was 34%, and 13.5. So if we add 68 and 13.5, we get 81.5%. What is the probability that a score is greater than 77? So that's actually the easiest way I can think of to do that is to tell you all of this is 50%. And then this is another 34. So what is the probability that a score is greater than 77? Would be 34 plus 50, or 84%. What is the probability that a score is less than 82? That would be 50%, or greater than 92. We want to count these guys too. You can add all those numbers up, or you could do this is 34 and this is 16, and those are the two that we aren't counting, right? Everything below 82 or above 92 would be everybody except the 34 or 16% that were in here. So that comes out to be 52.5. Did I have that, or am I on the wrong one? No, that's wrong. What is the probability the score is less than 82? I think my answer is wrong on here. This would be, or you could add all of the other scores, which would be 34 plus 13.5 plus 2.35 plus 0.15 going down to the bottom, and up at the top you'd have a 2.35 plus a 0.15. All right, either way, let's see, 100 minus 34 minus 16. It's not 16. That's my problem. This is 13.5. No wonder I have it wrong. Ugh. Let me confuse you a few more times. This is the way my whole day is gone, guys. This is not 16 in here. 16 is the next two combined. This is 13.5. So that's why I have in my notes that it's 52.5. Or if you add all these up, let's see, 34 plus 13.5 plus 2.35 plus 0.15. Going the other way, it's another 2.35 plus 0.15, and that's 52.5. Okay, or 52.5%. All right. Then it says how many of the actual students scored within 2 standard deviations. Oh, nope, it says outside the 2 standard deviations of the mean. Okay, within 2 is 95%. We want, so that leaves without, outside, would be the other 5%. So we need 5% of, and that was 120 test scores. So 0.05 times 120. Oh, I can't write today. Is 6 people scored further out than 2 standard deviations. Okay, the other 114 people all fell within 2 standard deviations. One more, I guess. It says gas is 205 and the standard deviation is 4 cents, so we'd have 209, 213, 217. Going this way, we'd have 201, 197, and 193. What percent? Okay, so there we just care about percent. Actually, we're going to have to use that 75 eventually, but what percent of gas stations sell a gallon for less than 197? That would be this going down. Okay, so I would say, so we can do 2.35 plus 0.15 in here is 2.5%. What percent of gas stations sell a gallon of gas for at least 217? So 217 and up. Well, that's a very small, at least 217. Right? That means 217 and up. Yeah. So it's only 0.15%. What is the probability that a gas station sells a gallon of regular gas for less than 197 or more than 205? Well, 205 and up is the full 50% because this was the mean. And down here, this was 5%. So if we have 50% and 5%, we're at 55. Why do I not have that? This was not 5%. It was 2.5%. Oh, trying to go too fast. My videos just feel too long lately. 52.5%. All right. About how many stations? So this is the one where we need to use the fact that we surveyed 75 stations. How many stations sell a gallon of gas for no more than 201? So 201 or less. Well, this was 2.5%, and remember this was another 13.5, right? Or we had a 50% and a 34%. So below that would be 16%. If you added those three numbers together, you get 16%. And 0.16 times 75 is 12 stations. All right. Now, not everything falls nicely on those standard deviation numbers. So in Prob and Stats, they use something called the z-score. And it is simply a way of measuring exactly how many standard deviations a data point is away from the mean, which they call mu in this case. When the z-score is positive, it means the data value is above the mean. When the z-score is negative, it means it falls below the mean. When z is 0, it's equal to the mean. Now the way to find a z-score is to take the value you're talking about, x, your data point, and subtract the mean and then divide by the standard deviation. Okay, so use this information over here. You get to use the formula, and I'm not sure that I asked, there might be one of these, but it says a radar detector records the speeds of a group of cars that pass by. If the mean is 46 and the standard deviation is 2.8, find the z-score for each of these data points. So if each of these is x. Okay? So the formula again is you take x minus the mean, how far is it away from the mean, and divide by the standard deviations, or 2.8. Okay, so it's exactly how many standard deviations above or below. Well, 52 is above, so 52 minus 46, and then we divide by 2.8. 52 minus 46, enter, divided by 2.8, is a z-score of positive 2.14. If we have a 42, that's below the mean, so it's going to turn out negative when we do this. And this turns out to be a negative 1.43. And I think z-scores, they actually only do to 1 decimal, and then they use a table most of the time to measure. We're going to use our calculator. So we have 47 minus 46 divided by 2.8. This is a positive 1 divided by 2.8. It's a positive 0.4 z-score. All right. So the mean number of total miles ran last week by each member on the track team was 4. This is the mean, with a standard deviation of 1.2. So if Clay's z-score was 2.5, oh, we have to work this guy backwards. How many miles did he run? We're trying to find x. So you would have the z-score was 2.5. The x is what we're trying to find. The mean is 4. The standard deviation is 1.2. We would multiply this over here. And then we're going to have to add 4. So 2.5 times 1.2 is 3. And if you add 4 over there, you get 7. So he ran 7 miles. I'm not sure that kind is on anything. All right. Then we're going to do one last little piece. We're going to talk about when data points don't fall exactly on one of those standard deviations. We can use what's called the normal CDF in our calculator. You can use z-scores, but we can also just enter the points we have. This is found on the distribution menu, which is quit here, second vars again. We used this, we did binomial probability, but today we're going to do normal distribution, and we're going to use number 2 only, the combined probability between certain data points. Okay, so we're going to do this normal CDF. And when we bring that up, this is what it offers, okay, which I put over here. We want to know the upper and lower score and the mean and standard deviation. If you use z-scores, these default to 0 and 1. But we can just use the data given in the problem as well. So here we have, we're going to use normal CDF. And it says the standard deviation is 6. The mean is 83, and what is the chance that the temperature is higher than 92? Okay, we want to know greater than 92. So when we go to the calculator, now if we were to draw this, I need to show you this one time. If we were to draw this, 83, and we started going up by 6 degrees, we'd have 89. The next 6 degrees of standard deviation would put this at 95. We want to know greater than 92. That's not on a standard deviation, and that's why we're going to use this key instead. And I specify in the questions, even on the quiz, whether you need to use this or the empirical rule. We're just doing this to exposure this year, guys. So greater than 92 means 92 is actually our lower limit. And then we're kind of tricking the calculator, so we're going to tell it the upper limit is. Now you could actually take the mean and add 4 standard deviations, or you can just put a really high number in there. I'm going to put 99999. And then the mean for this problem was 83, and the standard deviation was 6. And then if we hit enter a couple times, it will tell us the probability here is just 0.067 or 6.7%. And I don't remember how it asks on the calculator. On the Delta Math, you just have to read carefully what it says to do. So this turned out just to be 92, and then we just put a really high number in here, any kind of max, and it was 83 and 6. All right, a couple more of these and we're done. It says for this one, the mean is going to be 4.18. The standard deviation is 1.9, and we want to know the probability that they watch between 3 and 5. Notice 3 and 5 are nice numbers, and our mean and standard deviation are not. So this is not landing on an exact standard deviation that we could even estimate with the empirical rule. All right. So again, it's second distribution down to number 2. And this time they want to know what's the chance it falls between 3 and 5. So our limits are just 3 and 5 for lower and upper. And then we had some funky numbers here. We had 4.18 and 1.19. Okay, so we have 0.594 or 59.4%. Probability that it will fall in there. And I think I have one more. This one says the mean is 3 minutes and 3 seconds. So we probably need to do this all in seconds. So 3 minutes and 60 seconds would be 183 seconds with a standard deviation of 24 seconds. Find the probability the next song to play is no more than, so less than, 3 minutes and 45 seconds. So 3 times 60 is 180, plus 45 is 225. So our upper limit is 225, but a song can't be negative. So I'm just going to go to the distribution. And I'm going to say the lower limit is 0 seconds long. And we want to know all the way up to 225 when the mean was 183 and the standard deviation was 24? Oh no, 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 no. All right, so we have if you think about it, if the average song is 183 and we want to know what's the chance that it's less than 225, almost all of them are. That's why it came out 95.99 or almost 96%. All right, that's the lesson on normal distribution today.